Okay, we're going to go through the notes for Unit 1B, Day 6, Solving Absolute Value Inequalities. This is going to be similar to solving the absolute value equalities in that we have to find the positive and the negative. However, using inequalities is going to add some complexity to these problems, and you can read through these steps. The first thing we're going to want to do is figure out the sign we're working with, because that's going to be able to tell us whether or not this is going to be an and or an or problem, and it's going to tell us the number of intervals we're going to end up with. Since this question reads the absolute value of 2x minus 6 is greater than 10, we want to first look at this greater, and we're going to say greater, and that's going to tell us how many intervals we're going to have. We'll talk about that at the end, but this is how we're going to separate these two problems. Setting up the first part of the problem is going to be pretty intuitive. We're just going to remove the absolute value bars, and we're just going to say 2x minus 6 is greater than 10. The change is going to occur when we do the 2x minus 6, and we need to consider that negative solution, because not only are we going to change that 10 to a negative 10, we're going to change the greater to a less than symbol. Once again, we're going to just work this problem, so I'm going to add 6 to both sides. And you can work these, at the same time is just fine, because this way it keeps your inverse operations true. So I end up with x is greater than 8 or x is less than negative 2. Now I'm going to come down here to take care of the inequality, which we just figured out. The interval we'll get to in a second, but let's talk about the graph first. So what I'm going to do is I'm going to plot my two endpoints of my interval. So I have my negative 2, and I want all the numbers less than negative 2. So I'm going to shade in to the left, and I'm going to leave that open. Same thing over here when I get to 8. It's going to be open because it is not equal to, and I'm going to shade to the right because that represents all the numbers greater than 8. Now I like to take that graph and use that graph to help tell me about what my interval will look like. Now remember, we have negative infinity over here, and over here we have positive infinity. So I have two areas of my graph shaded, of that number line shaded. So I'm going to end up with two intervals. So you see I have one that goes toward negative infinity and comes up to negative 2, and it stops, and that's a closed interval. And then I have another endpoint at 8, and that is going to continue toward positive infinity. I always use the parentheses as a reminder from that lesson a couple days ago with positive and negative infinity. These endpoints will also have parentheses because that's an open interval, because negative 2 and 8 are not included, and I can't just leave these two intervals floating out there, so I have to put the U because I'm talking about all the numbers less than negative 2 or all the numbers greater than 8. This problem over here, we're going to do the same thing, except we're working with a less than. So in the directions above, you might have read through those steps, and less than is an and, so we think of it as less than. And I can work this as a compound inequality, but let's just separate it with and see what happens. So I'm going to do my positive version of the problem, and I'm going to do my negative version of the problem. And remember, when you do that negative version, you have to flip the inequality sign as well. All right, now let's work these two problems. We'll end up with our inequality and then see what happens. And we'll do this inequality a little bit differently because it'll help us kind of get our graph going, and it'll make the interval of our solution a little bit more obvious. Okay, so I'm looking at all the numbers where x is less than 3, less than or equal to 3, and then remember this is and, so both of these conditions must be met. So my numbers have to be greater than negative 7, greater than or equal to negative 7, and at the same time less than or equal to positive 3. So an easy way to write this, so we have our x value needs to be less than or equal to 3, at the same time greater than negative 7. So I like to keep that inequality stuck together because it makes the interval easier to write and the graph easier to do. However, I can keep those separated and use the word and. Either one is okay. So now I'm going to go ahead and graph that interval, and you see that my solutions live in between -7 and +3, and they include 7 and 3. One interval of the graph is kind of shaded in, so we want to make sure that my solutions go from 7 to 3, and they include 7 and 3, so we have to use brackets this time instead of parentheses. So we're only going to do 2 more examples here because I want you to get as much practice as possible on the homework, and these problems can be time consuming. So why don't you go ahead and try these. As you try these, make sure that you remove the absolute value bars and keep everything the same, really, with the exception of the absolute value bars for that positive part of the problem. And then when you separate it and do the negative part, not only are you changing the answer to negative, but you're also flipping the inequality. So go ahead and work these 2 problems. When you're finished, you can unpause this and take a look at the solutions and then move on to the homework. Okay, so a brief run through. For example number 3, we're going to have 3x minus 7 is greater than 7, or 3x minus 7 is less than -7. We choose to use the or here because it is greater. So once we figure out that it's or, then we forget about it. We're going to go ahead and solve it. I get my 2 values, x is less than 0 or x is greater than 14/3. It doesn't matter really where exactly that 14/3 is, you just have to realize it is greater than 0, so it has to go on the right side. We want to make sure that our number line is in the correct order. So we shade in all the numbers less than 0, all the numbers greater than 14/3. We show our 2 intervals, and we have to make sure that we connect those with that U symbol. Going up to example 4 again, I see this less than, so that's less than, so I choose the and then I go ahead and work those 2 problems again, remembering to switch the one on the right, which has the -11. Now this problem does add a little bit more detail here, because when I get to that step with the -2x and I'm dividing by 2x, I'm dividing by -2, you'll notice that the inequality flips again here and again here. Okay, and if you don't do that, we won't end up with the right graph and the right intervals, or the right interval in this case. So my answers are going to be greater than or equal to -1 and less than or equal to 10. So you see that interval, you see what that graph looks like. There's one interval that's shaded in, so my interval should reflect what I'm seeing on the graph. All right, so now that we've worked through some examples, go ahead and work on worksheet number 6. And please use the key for worksheet 6 to go ahead and check your work to make sure you're on the right track. Thanks.